Welcome to this session. This session, you're going to do examples on how to apply chain rule for differentiation of function of a single variable. Now, the first problem is to differentiate y equals to 1 plus square root of x squared plus 1. So let me start with this b. B is much easier than even the first one. So solution, you let u to be x squared plus 4x plus 3. So call this y. So y will now be u raised by 2022. So du dx will be 2x plus 4. And then dy du, you drop 2022, then subtract 1, 2021. And so dy dx is dy du times du dx. So that we'll have dy du 2022 u power 2021 times du dx, which is 2x plus 4. And so this is the same as, actually we can factor out 2, so we'll have 44 into x plus 2, factoring out to this multiplied by this, then u power 2021, which will give us dy dx is 44 x plus 2, and then u is x squared plus 4x plus 3 raised by 2021. So that is the answer to part B. Now coming back to this, so solution for part A, let u, small u, to be x squared plus 1, and let capital U be 1 plus root u, because this part are fixed by small u, which is the same as 1 plus u raised power half. And so by that substitution, y will be capital U raised power half, because everything that is inside the square root sign is capital U, and then square root is the same as raised power half. So I can call this one equation 1, this one 2, this one 3. So dy, the capital U, so du dx from 1 is 2x. This from 1. And then the capital U, the small u, this second equation is a half u raised power minus a half. This from 2. And then 3, dy the capital U will be a half capital U raised power minus a half. This from 3. And then by definition of chain rule, dy dx, for this case will be given by dy the capital U times the capital U, the small u times the small u dx. So which will be a half capital U minus a half times a half small u raised to minus a half times 2x. So you see this and this cancels out. So you have a half x small u raised to minus a half, and then capital U raised to minus a half. Remember, small u is x squared plus 1. So this will be a half x squared plus 1 raised to minus a half times capital U is 1 plus square root of small u. So it's 1 plus x squared plus 1 raised to a half, and then raised to a negative a half. So this is dy dx, this is dy dx. So with this, we can write it as dy dx equals to a half. Actually, this is the same as x over 2 square root of x squared plus 1 times 1 over square root of 1 plus square root of x squared plus 1, or you can write this one as dy dx equals to x over 2 root x squared plus 1, and then root 1 plus square root of x squared plus 1. That's what we have. So this is the dy dx of the given function. Thank you.